So hi everyone and welcome to module number 2. So this video will now be discussing module number 2, which is on compounds and chemical bonding. So we'll be having 2 weeks of this topic for our class. So for this asynchronous session, we will just be discussing the first two topics of module number 2. So let's first start off with electrons and chemical bonding. So this will be like the scope of our discussion for the next 2 weeks. But I will just be discussing the first two topics, which is on electrons and chemical bonding and electronegativity and bond polarity. Okay, so let's have the transfer of electrons first. Compounds formed when electrons are transferred or shared between atoms to give stable electron configurations to the atom. So technically speaking, our whenever we're talking about atoms, the outermost portion of the atom, there are electrons that are moving on that side. Now the thing is, an atom is said to be stable if it has 8 electrons on its outermost shell. But in most cases, it doesn't happen that way. That thing is only possible for noble gases. Okay, but for most atoms, the last shell would only have atoms that are less than 8. Okay, so atoms could lose, gain, or share valence electrons to acquire an octet of 8 valence electrons. So this is what I've been telling you about that for compounds to form, you need to have like a complete set of 8 valence electrons. Now we have different kinds of bonds when it comes to the formation of molecules. So like what I've said before, bonds are like the glue that puts the atoms together to form molecules or to form compounds. So bonds ionic bonds occur when valence electrons of atoms of a metal are transferred to the atoms of nonmetals. So we're talking about two different atoms. One is a metal and the other one is nonmetal. So there's a transfer of electrons from the metal atoms to the non-metal ones. Then we have what we call as ionic bonds. Now, an example of this would be for sodium atoms, they could lose electrons, and chlorine atoms, on the other hand, gain electrons to form the ionic compound NaCl, or what we call as table salt, which is sodium chloride. Now, when we talk about covalent bonds, these bonds occur whenever you have atoms of both nonmetals. So a while ago, when we say ionic bonds, that's between a metal and a nonmetal. But for covalent bonds, it happens between two nonmetals. Okay, so for example, we have here water, which is H2O. H is hydrogen and O is oxygen, so they are both nonmetals. And then the other one is propane, which is given by C3H8. C here is carbon and H here is hydrogen. So we have two nonmetals working here. So in this case, in these molecular compounds, what we have there would be covalent bonds. Now, with the transfer of electrons, what happens is that we form what we call as positive ions and negative ions. So positive ions are formed whenever we lose electrons. So because the ionization energies of metals of groups 1A, 2A, and 3A are low, metal atoms readily lose their valence electrons, so making them positively charged ions. Okay, so for example, if we will take the case of sodium, in sodium, the atomic number is 11. So that atomic number represents the number of protons that you have for that atom. So if, for example, you have a sodium atom, which is what we call as neutral, ibig sabihin, it's not positive or it's not negative, the net charge is equal to 0. So that means you have an equal number of protons to the number of electrons. So in this case, we have 11 protons and 11 electrons. Now, what happens if the sodium atom loses one valence electron? So once it loses that one electron, what happens now is you have more protons compared to your electrons. So the scenario now will be you'll have 11 protons, which are positively charged, and then now you have 10 electrons, which are negatively charged. So as a result, if like in math, in algebra, if you will add this, you have positive 10 plus negative 10, what you will have is positive 1. So that's why your sodium ion here becomes positively charged. And here you say that this atom now becomes an ion. So in principle, you will also have negative ions if in this case naman, you gain electrons. So the ionization energy of a non-metal atom in groups 5A, 6A, or 7A is high. So which means that non-metal atoms do not easily lose their valence electrons, but instead, they actually attract. Okay, they attract the electrons coming from other atoms. So a non-metal atom gains more one or more valence electrons, making it a negatively charged ion. Okay, let's take, for example, the case of chlorine. So chlorine as an atom, if we will say that it is neutral, if you will look at your periodic table, the atomic number of chlorine is 17. Okay, so that 17 there corresponds to the number of protons that you have. So if the chlorine atom is electrically neutral, then we say that the net charge is equal to 0. So that means you have equal number of protons and equal number of electrons. So if you have 17 protons, that also means you have 17 electrons. But what happens if that chlorine atom attracts one electron? Okay, so if it now attracts one electron, so instead of 17, you will now have plus 1. So that's 18 electrons moving. So what happens now is that you'll have 17 protons and 18 electrons. So in just like in math, okay, so if you have positive 17 plus negative 18, what you will get is negative 1. So that means your chlorine atom now becomes an ion and it becomes a negative ion because it is now negatively charged. In terms of chemistry, when we say a positively charged ion, that means you have more protons than electrons. But when you say a negatively charged ion, that means you have more electrons than your protons. Here's a table of some important metal and non-metal ions. So if you notice here, the group number also corresponds to the charge of your ion for all the cations. Now, example here for the case of non-metals, you would notice that for group 5A, you have nitride and phosphide, and they both have a charge of negative 3. And then for 6A, group, you have oxide and sulfide. You would notice here that you have negative 2 for both. And then for the 7A group, you have fluoride, chloride, bromide, and iodide. All of them would have negative 1 as like their charge. Okay, so there seems to be again like a pattern here. Now, if you notice as well, in your periodic table, this charges could also correspond to your oxidation numbers. Okay, the oxidation state can also give you the charge, okay, that you have whenever you have cations and anions. So let's take note that the physical and chemical properties of an ionic compound such as sodium chloride are very different from those of the original element. So I have here a very good illustration of that. So when we say sodium, one of the characteristics of sodium is that it is highly reactive and it explodes in contact with water. So it's a very dangerous element. Now, chlorine as well is also a very poisonous and a deadly gas. But if you combine them together, well, you have sodium chloride. Okay, it actually becomes a food preservative and a flavoring, right? A flavoring agent. So now let's look into electronegativity and bond polarity. Now, electronegativity, if we want to define it, this is defined as the ability of the atom to attract the shared electrons in a chemical bond. And in some cases, they also define electronegativity as like the difficulty to remove an electron. Okay, so in this case, we also say that non-metals have higher electronegativities than metals. Okay, why is that? Because non-metals are better at attracting electrons. They do not lose electrons, but what they do is that they attract electrons. So non-negativity values for noble gases because they do not typically form bonds. So if you would notice, if you would look at the oxidation states on your periodic table for the noble gases, most of them is 0, okay, because they do not actually react with other elements, okay, so that's why their electronegativity values are like equal to 0. Now, what I have here is a table. If you will look at your periodic table, you will also see there the electronegativity value. So, again, if we will review this, our electronegativity increases as we move from left to right, and it decreases while we move from top to bottom. Okay, so you will also see the electronegativity values on your periodic table. Let's take note that these electronegativity values can be very useful for us to predict the type of bond that will form whenever you have two atoms reacting together to form a compound or to form a molecule. Now, the difference in the electronegativity values of two atoms can be used to predict the type of chemical bond, whether that's ionic or covalent, that could possibly form. Polar covalent bonds, on the other hand, exist between atoms with identical or very similar electronegativity values. So, for example, if the difference between the electronegativity values is equal to zero, then we can assume that the type of bond that forms there is a nonpolar covalent bond. Whereas, if the electronegativity values are very different, okay, so if we will be able to get a certain value for their difference, we can say that the type of bond that exists there is a polar covalent bond. Now, also remember that the polarity of your bonds depends on the difference in the electronegativity values of its atoms. So it depends on the values. So a bond becomes more polar as the electronegativity difference increases. Now, it also happens that if you have a polar bond, a dipole could occur. We say that it's a dipole if it has a separation of charges. So that means one side is positive and the other side is negative. So the positive end is represented by the Greek letter delta, and then you have plus as your superscript, and then the negative end is represented again by the Greek letter delta, and you have negative as a superscript. So a classic example of that is what happens when you combine hydrogen and chlorine. Okay, so when you combine them, since they have very high electronegativity values, so they form a polar covalent bond. Now, what happens is that the unequal sharing of your electrons in a polar covalent bond could cause one side to become positive and the other side to become negative. So in this case, if you would notice here, hydrogen is more inclined to have a positive charge, and then chlorine would likely have a negative charge. Why is that? Because chlorine contains more electrons compared with your hydrogen. Now, this is the table at which we'll be able to determine the type of bond that exists between compounds or molecules. So if the electronegativity difference is 0 to 0.4, then the type of bond that could form with that is a nonpolar covalent one. And in here, we say that electrons are shared equally. So if you will imagine this in a form of an illustration, imagine like the molecule will be like this, like it's equally distributed. Okay, so for the electrons of both um atoms. On the other hand, if the electronegativity difference is between 0.5 to 1.8, then what we have there is a polar covalent bond. And the electrons shared here are very much unequal. Okay, so you can imagine like your molecule would look like this, like one side could be positively charged and then the other one is negatively charged. Now, on the other hand, if you have an electronegativity difference of between 1.9 to 3.3, then the type of bond that exists is ionic. And in this case, you would notice that for covalent bonds, you only have a sharing of your electrons. But for ionic, remember that here the electrons are transferred. So in this case, they would look like this. Okay, so there's like a separation between the two atoms, but they are still glued together by what we call as your ionic bond. Now let's have here an example of how we predict the electronegativity differences. So if we look at here, for the formula H2, this is hydrogen gas. So what kind of bond exists there? Now the electronegativity value of hydrogen is 2.1. Since you have here two atoms of hydrogen, so that's 2.1 minus 2.1, you get a value of 0 for the difference. So that means since this one is 0, that means that the type of bond that you have is a non-polar covalent. So if we will go back to what I have shown you earlier based on this table, okay, you have here non-polar covalent. Okay, so for example here, for the second one, we have bromine monochloride. So for bromine monochloride, you have here the electronegativity value of bromine is equal to 3, and the one for chlorine is 2.8. So the difference between the two is zero point 0.2. So since this one is in the range of 0 to 0.4, therefore we say that here you have a non-polar covalent bond. Now for the next one, you have hydrogen bromide. So for hydrogen bromide here, the electronegativity value of from hydrogen is 2.1 and that of bromine is 2.8. Okay, so you have your difference of 0.7. So that's why here, if you would look at our table, so that's between 0.5 to 1.8. So therefore, what we have here is a polar covalent bond. And the next one for hydrochloric acid. Okay, so this one is H3L. So again, for chlorine, the um, electronegativity value is 3, and then 2.1 is the electronegativity value of hydrogen. So if you get the difference of that, that's 0.9. So this is relatively higher. So remember that if you have a higher value, if therefore it now falls on the range of this one, 0.5 to 1.8. Therefore, we say that it is polar covalent. So if you're watching this video now, you can try and pause this one and try to answer this question. So using the electronegativity values, classify the bond between each of the following pairs of atoms. So we have potassium and oxygen, we have nitrogen and nitrogen, arsenic and chlorine, and you have phosphorus and bromine. So what I have here would be the electronegativity values. So again, you can pause this video and then try to answer this one first before I show you the final answer. So if you have answered the try this section, this is the answer to the question. So for number one, you have a difference of 2.62 for potassium and oxygen. So therefore, this one is an ionic bond. Then for number two, you have nitrogen and nitrogen. So the difference is 0. So that's why we say that that is non-polar covalent. For number three, you have arsenic and chlorine. So the difference is 0.98. So for that one, that is polar covalent. And for number four, you have potassium and bromine. So the difference between the two is 0.77, which again falls under the polar covalent bond. Okay, so with that, I hope that you were able to understand the lecture. After this, you will be taking the quiz. So take note of the availability of the quiz online and make sure that you also have your periodic table with you. Although I will be providing the electronegativity values, but you should have like the table of the electronegativity values ready for you to answer questions that are related to this one. So with that, guys, thank you so much, and I'll see you again on the next video.